In this video, we'll be covering the basics of how to solve polynomial and rational inequalities. The first thing we're going to cover is the basic steps to doing so. In this case, the first step is going to be rewriting the polynomial, whatever you have, possible rational function, as greater than 0 or, again, less than 0. Now, with this particular statement, again, they could be or equals. Okay, so it doesn't have to just be greater than or less than. It could be greater than or equal to and greater than or less than or equal to. So that's your first step. Your second step would be to solve as though you're treating it as the polynomial or the rational function is equal to 0. These particular identifications, the values that you're going to solve for, we would call those the boundary points in some way. They're the locations where the polynomial would be equal to 0, not necessarily that it has to be equal to 0, but it will help you distinguish where the separators are, where it could change from positive to negative or negative to positive. After that, number 3, you're going to go ahead and draw yourself a number line. And then number 4, I would say, is you're going to pick intermediate values. In between values might be another word you might want to use. These particular values are the values that you're going to use to test your inequality to make sure that it appropriately works. Now, these two details together, the number line with the in-between values, this is something that calculus individuals would recall as the number line test. Okay, so those are the basic steps to evaluating a polynomial inequality. Let's take a look at a real basic one to start. So our first example is going to look like x squared minus x is greater than 20. So you'll notice here that this is a polynomial. Again, most polynomials can be considered as quadratics or cubics and other sorts. So this is a quadratic, but it is also considered a polynomial inequality. Now the first few steps we're going to do with this again is make sure that we can rewrite it as though it's greater than 0 or less than 0. And again, it doesn't really matter which way we go about this because the algebra details, the variables, are going to account for themselves when it's all said and done. So what I'm going to do is I'm always going to focus on my x squared, my largest power of x term, to be positive. So that means I'm going to subtract 20 from both sides of this inequality. I'm going to treat it as though I'm looking at, again, an equals to 20. So it's greater than, but when I solve this, I'm going to solve it like it's equal to. Then what I'm going to do is I'm going to ignore the fact that this greater than here was there all for now, and I'm going to go ahead and set it equal to. So off to the side here, I'm going to go ahead and set this equal to 0, and I'm going to solve this like I would normally any other equation. So in this case, to solve this quadratic, I'm going to go ahead and either use factoring or the quadratic formula. It does look like factoring should work just nice, and it'll factor into those two values. Then I'm going to go ahead and solve each individual factor separately, so x equals 5 and x equals negative 4. So those are the two locations where the polynomial could change its direction. Again, this particular polynomial has to be greater than 0. These are the locations where it should be equal to 0. This will tell me, again, where it could potentially, not where it has to, but where it potentially changes its values from positive to negative, negative to positive. So the next thing I'm going to do is I'm going to draw my number line test. Again, the number line test is simply just drawing a number line. I like to put negative 4 and 5 on here, specifically the values. If there's more than 2, then write all of them, all the values where the polynomial or the rational function could equal to 0. In this case, because there's no equal sign on this, I'm going to put open circles at those locations. Again, the important part is that if there was an equal sign, then those would be solid dots, or could be solid dots in some way. Below this, I'm going to go ahead and draw myself some lines down here, and then simply create myself, again, a table. The first section is the TB, or the test value, is what I end up calling it. The test value is the value of the number that you're going to plug it back into the original inequality to verify whether or not it's going to work for that number. So a value that's in this section. Now, it might be difficult for us to better understand what's going on here. So up here, I'm going to go ahead and write int for the interval that each section is in. In this case, I'm going to go from negative infinity all the way to negative 4, and I should probably go ahead and use an open parenthesis because, again, this value is not included. This one here is going to be negative 4 to 5, and then this will be 5 to infinity. Again, this setup here is absolutely necessary to know what your answers are going to be. It is important that maybe you might want to leave an extra column here and just leave these things separated. But again, you'll notice it's real easy to write out these intervals, separating the entire number line into the separate pieces it needs to have. So the test value that I'm picking is simply going to be a value in this interval. So -5 seems like a nice smooth value to pick. In here, I'm definitely going to go for 0 or 1 if I can. And then over here, I'll go ahead and plug in 6. So those are my test values. All this space down below is just going to be my plugins. Okay, I'm simply going to go ahead and take this -5. I'm going to plug it back in to the original inequality. Now, yes, technically you can plug it in here. Heck, you can even look at it like this, as x minus 5 times x plus 4 is all greater than 0. You could look at it that way and solve it that way by plugging it in there. But here's the kicker. If you make a mistake in any of the steps going from here to here, then all of your plugins are going to be incorrect. So it might be safer to plug it into here. Now, if you trust yourself, again, you can go ahead and take this -5 value and plug it in here. Now, you can plug it in here and, again, plug and chug with a calculator. The reason why I would prefer to plug it into this factored form, again, if I feel comfortable with my math, plugging it into this factored form is probably the most efficient way. And the reason why is if I plug -5 into this x, it's -5 minus 5, so -10. Then I'm going to plug the -5 into this here, x, and I'm going to get -5 plus 4, so that's going to be -1. And -10 times -1 is going to be greater than 0. And sure enough, that section is going to check. Okay. Again, if we plugged it in up here, I'm going to have -5 squared, which is going to be a positive 25, plus 5 because it's going to be minus minus, and that's going to be 25 plus 5, so 30. 30 is greater than 20, and therefore would also check. So again, notice you can check it back up here. As long as your math down here does work out, you can check it down here as well. So now you can start getting a little bit more, again, efficient, I would say, with this. Even though lazy is the more appropriate word, but efficient is accurate. Now I can just start plugging these numbers in down here if I feel comfortable. Again, if I feel comfortable that I've done the math right. So when I plug in 0 here, that first term is going to be negative. I'm not even going to worry about the number, because if I plug in 0 for this one, I'm going to get a positive, and negative times positive is less than 0, and that section is therefore not going to work. Okay. In this case, again, all you're doing is you're just testing the number in this term, and I know that this term is negative or positive, and this term is negative or positive, and I can identify whether or not negative times negative is positive, positive positive is positive, and everything else is going to be negative, and therefore isn't going to be what I want. When I go ahead and plug in the final value 6, I'm going to get a positive times a positive, and therefore positive times positive is greater than 0, and therefore that section checks out. With this setup, I can now identify clearly what my answers are. In most cases, to solving these polynomial inequalities, the question will ask you to graph the solution on a number line. In that case, wherever I have a check mark, I'm just simply going to go ahead and draw myself an arrow or a line in that section. Here's my graph with the number line. I'm going to go ahead and very carefully circle all that. You don't have to circle all that. It should make sense in terms of what your answer choice is. Now, this is the graph, but what is my actual solution? Well, my actual solution to this problem would be all the values from -infinity to -4 unioned with the values from 5 to infinity. And again, because there's no equal sign on this original problem right here, I don't need brackets on those two endpoints there. So again, those are the 4 steps in terms of how to solve a polynomial inequality. This basic one being a quadratic. There can be more complicated ones. It can lead to having more of these number line separations. But overall, again, it's identify, get it equal to 0, or inequality to 0, set it equal to 0 and find those boundary points, and then do your number line test, which again is this entire box. That completes that particular steps. Be very careful, again, making sure that you test your values back into the original. If you don't test them back in the original, make sure you're comfortable with your algebra getting to here, and you can test them there for a little bit more efficiency.